Hey guys, so what we're going to be doing today is talking about how to interpret arterial blood gases and otherwise known as ABGs, not the rave kind. So the first thing that you want to do is look at the pH. So this just determines whether the pH of this patient's blood is above or below the neutral pH. The second thing you want to do is look at the carbon dioxide levels and look at the bicarb levels in the blood as well. So that sort of helps you delineate whether it's a respiratory or metabolic cause of this acidosis or alkalosis. And after you've done this, then you're looking at compensation, which is essentially what the body is doing in an attempt to correct the issue that you've got with like the weird pH that's happening. All right, so we're going to go into a little bit more detail on how to actually do that. So the first thing you want to do it again is look at the pH. And we've got the normal range here from 7.36 to 7.44. So we're going to look at the acidosis side first. So if it's anything less than 7.36, then you can immediately be like, okay, that's acidosis. So then you're looking at CO2 and bicarb to figure out, is it respiratory or is it metabolic? So keeping in mind that carbon dioxide is acidic and bicarb is basic. So when you have acidosis, it's either because you have really high levels of carbon dioxide or really low levels of bicarb. And again, you see that here, and you can determine that looking at your normal ranges, which for carbon dioxide, the upper range would be 44, and for bicarb, the lower range would be 22. So if you have really high carbon dioxide, then you can conclude, yep, that's respiratory acidosis. And if you have really low bicarb, then you can go, yep, that's metabolic acidosis. And like a way to remember that is that like carbon dioxide is a gas, you breathe gas, you breathe like in oxygen and you breathe out carbon dioxide. So therefore, like I like to think of it as being respiratory, and bicarb is like an ion. So it's like dissolved in your blood. So I sort of think of that as being metabolic. So conversely, you can also think about the pH being too high. So when it's above 7.44, then you can smack bang go, okay, that's alkalosis. And then again, you want to be thinking about what is causing this alkalosis. So it's either because you've got really low CO2 value. So again, CO2 is acidic, so low levels would cause alkalosis, and bicarb is basic. So high levels would cause the thing to be very basic, so alkalotic. And you follow that sort of principle to get to respiratory alkalosis with very low carbon dioxide, and metabolic alkalosis if you have very high bicarb levels. So next up, after you've determined whether it's respiratory or metabolic, and if it's acidosis or alkalosis, you want to be looking at compensation. So this is like a question of, is the body actually doing enough to compensate for this decrease or increase in pH? So this is just a little bit of a reminder of like what sort of picture you'll be seeing with your ABG numbers. So with respiratory acidosis, you'll have low pH, high CO2, which is why you've decided it's respiratory, and you'll also have high bicarb because the body is likely trying to compensate and attempt to drive this pH up. And respiratory acidosis usually results from hypoventilation, which is where your CO2 stays in the body because you're not breathing it out. And you want to look, so with all of the respiratory issues, you're going to be needing to look at the clinical picture to determine if it's an acute or chronic picture. So this person's had this thing for ages. You can probably say it's chronic. And if it's like a very like sudden onset, then it's more likely going to be acute. And once you've determined whether it's acute or chronic, then you can figure out if the body is compensating enough given this like clinical setting. So with an acute picture, every increase in 10 in your PCO2 should correspond with an increase of 1 in your bicarb, and an increase in PCO2 of 10 in a chronic picture should increase your bicarb by 4. So if this like number isn't reached, then you can say in the chronic setting this isn't fully compensated. And this doesn't, we'll do some examples and hopefully that will make a little bit more sense when you actually apply these numbers. But really, compensation is a lot of remembering numbers. All right, so we're going to move on to respiratory alkalosis. So again, running through this very quickly, pH is high, so it's alkalosis. PCO2 is low, therefore you're concluding, okay, this is because it's respiratory. The alkalosis is due to it being respiratory, and your bicarb is low as well because you're trying to compensate and attempt to drive this pH down. And this is like the opposite to respiratory acidosis. So this is due to hyperventilation. So your CO2 is constantly getting blown out of the body. And so there's like very low levels of it in the body. So again, you're looking at the clinical picture to determine if it's acute or chronic. And the proportions that you'll be looking at for alkalosis would be 2 to 10 and 4 to 10. Okay, on to metabolic acidosis and alkalosis. So with metabolic conditions, you don't have acute or chronic picture. And that's because respiratory compensation usually occurs very quickly. Your body can very quickly adapt to these like metabolic changes by just like breathing more, breathing less. So you just basically just looking at one equation for each of these. So going through metabolic acidosis, low pH and low bicarb, which characterizes as at being a metabolic acidosis, and your carbon dioxide level will also fall and attempts to compensate and drive this pH up. So your expected PCO2 compensation would be 1.5 times your bicarb plus 8, and remembering that you're actually using the number for HCO3 here. So you're not actually using like the difference between the normal range and what you're getting. You're using the actual number that you see in the ABG, and your expected PCO2 compensation should be the actual number you'd be expecting to see in your ABG as well. So if that doesn't match up, then your metabolic acidosis is not adequately or fully compensated. So with your metabolic alkalosis, again, pH is a little bit too high, and your PCO3 minus is also too high, which is why you've decided it's metabolic, and your compensation comes from your PCO2 going up. And this equation is slightly different, 0.7 times bicarb plus 20. Okay, so with that all out of the way, and that now that we've given you a framework on how to actually work through these numbers, I'm going to work through this one with you. So we're not going to look at the clinical picture just yet, but we will if we need to come back to it. So we're going to look at the pH first. We see that it's 7.25, which is quite low. So it's on the low side on this side, which is why we can say it's acidosis. Then you'll be thinking, okay, so where does this acidosis come from? Acidosis can either be caused by this being too high or this being too low. So then you want to look at the value ranges. Values in comparison to the ranges, and you see that your PCO2 is pretty low, so that doesn't correspond with that, but your bicarb is also low. So this is the cause of your acidosis, which means that you've got metabolic acidosis. Okay, so let me just write that here. Right, so third step would be to look at compensation. So for metabolic acidosis, you'd be looking at the respiratory system doing the compensating, which means that you don't really need to look at the acute or chronic picture because there's only one equation. And your equation, if you remember from the previous slide, is this CO3 minus plus 8. And that should give you your PCO2 expected level. So if you want to plug the numbers in, 1.5 times 10 plus 8 equals to 15 plus 8 equals to 23. So this is pretty close to what you're seeing here with the 24. So we can pretty much say this is like fully compensated. And so your like final answer would be metabolic acidosis that is fully compensated. Okay, so here's another example, and it'd be so a lot of learning how to read ABGs is really just going ahead and doing it yourself. So I'd recommend you pause this and have a go at working out what like sort of picture this is and like what the compensation is as well. So pause now to have a go at that. All right, I'm going to assume that you have given this a go. So again, we'll work through this together. Right, so first thing you want to do is, again, look at the pH. So this is low, which is why we can say, okay, that's acidotic. Then you want to think, okay, what's causing this acidosis? So again, your PCO2 should be high in an acidotic picture, and your bicarb should be low if it was a metabolic cause in an acidotic picture. And you see that your PCO2 is actually quite high. So then this is actually the cause of your acidosis. Respiratory acidosis. Right. So now that you've determined it's respiratory, you want to determine, okay, am I looking at more of an acute picture or chronic picture? And that's how you'll decide whether the compensation is like enough. Okay, so then you go back to the stem and you're reading some dude with a history of COPD. Oh, yeah, key, that's chronic. So you would probably be looking at using the compensation like ratio that's for the chronic respiratory acidosis. And that is 4/10. And so a change in your CO2 should correspond to a certain amount of change in your bicarb. So this is increased by 15. So a 10:4 ratio should correspond to a 15:6, like quick math, which means that your 24 plus 6 equals 30. So 24 is just grabbed from this like normal reference range. And that should give you 30 for your HCO3 minus expected compensation. And so we can say, yeah, that's pretty much fully compensated. And the final answer for this would be respiratory acidosis with full compensation. So the reason that we're using this like plus thing is because the ratio here that we've got, if we go back to looking at the compensation rules, you're actually looking at the increase in bicarb and the increase in your CO2 as well, instead of using the actual number that you've got. And that increase is in relation to like the normal range middle value. Okay. Yep. So that is pretty much all we've got for you today. Definitely would recommend looking up some more examples and going through them. But Pace Pupper is always happy to take questions if you've got any. Thank you for listening.